Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
Stingray, you want me to present your screen? How you doing, brother?
Yeah, go for it. I got a question for Lennon about the top half and bottom half of vision.
Yes.
Can you see my screen, Lemon?
Yes.
Okay, so I've got a camera here, and I'm looking at a vessel. So is your contention that the bottom half of this lens, or vision, whatever you want to call it, is going to form a horizon line which will hide the ship as we move away, correct? And it's and as far as I can tell, you're saying it's because it's the bottom half of the lens. Now, the lens is an aspherical lens element. They all are. In other words, they're just squished spheres. So, how are you dividing it by half? What says this is the bottom and the top? Because with a sphere, it's just omnidirectional. Even if it's squished in one of the axes, it's just a 360-degree sphere, basically. So, is it the thing closest to the ground, which is the bottom half? Is that how we define it?
When you look down a hallway, you see a bottom half that ramps up. I don't know what else to tell you.
No, not
other
about
than the
perspective.
bottom half of vision from that point.
Yeah. So I'm not on about perspective here. So this whole program is perspective.
So since you see that in a hallway, that gives you a top and bottom half of vision.
Well, that's just a hallway. You're saying the top and bottom half of vision. So the top and bottom half of vision is nothing to do with the lens or your eye. It's
Obviously,
to do with
you see that outside as long as the conditions in the hallway hold for outside. As long as something outside maintains its elevation and goes away parallel to where you're looking, well, then the same conditions would apply.
Okay, cool. So it's actually nothing to do with the top and bottom half of the vision of your eye. It's actually because there's a ground and a ceiling, then, let's say. Is that fair to say?
I'd say that's pretty fair to say. You're close to the ground, yeah.
Right, so it's absolutely nothing to do with the top and bottom half of vision. It's actually to do with your proximity to the ground, correct?
Yeah, your proximity to the ground leads to a top and bottom half of vision.
Well, it really
actually,
doesn't.
You still see it even in open spaces. So even in open spaces, anything that is above the level of the eyes will appear to ramp down towards you. And even in open spaces without a ground in the way, something below the level of the eyes would appear to ramp up towards you as long as it's going parallel. So the same phenomenon still appears to apply. There's a top and bottom half of vision.
All you and Gary keep saying is perspective, and that's very well understood, but does not account for the things that you want it to. So I'm trying to
give you a top and bottom half, though. So I don't understand why you can't apply the top and bottom half that you see in a hallway to generalized vision. For some reason, you're making an application in one area but not the other.
Yeah, I'll show you why. So can you see the screen right now? Yes?
You can see it.
Okay. So what is the bottom and top of my vision now? Is the boat anywhere near the bottom half of my vision?
The bottom half would be the part that ramps up. The top part would be the part that ramps down.
Right, I'm seeing no part that ramps down now. The top of this lens is pointed at the very short body of water horizon. So the only thing in this field of view for this lens, for this camera, is everything that ramps up. Is it fair to say then that this entire lens is the entire bottom of the vision? Is that how you're portraying this phenomenon?
It would be the part that ramps up. As long as something goes way parallel to you and ramps up, that's the bottom of your vision.
Right. So now everything in this lens is the bottom of the vision, correct?
Since it's ramping up by its ramping behavior, that's what one would assume. You're just reorienting the way that you're looking at the scene, but you still have a top and bottom half that you're just reorienting your lens toward. That's all. But the bottom portion would still technically be the part that's ramping up, if you want to talk about ramping behavior, being what tells you what's the top or the bottom half.
Right. So the issue that you've got with saying top and bottom half is the half is related to absolutely nothing. And when you say top and bottom of vision, you don't mean that. You just mean the surroundings and perspective. Because if we take this, for example, and I look up at the sky, the only thing the sky is doing is appearing to converge all the way down, and that's it, nothing else. I'm not even looking at the water now. So there's no top and half of vision, no top and bottom of lenses and stuff. It just so happens to be, you know, the surface is involved. I'm trying to get more to it now. So now that if I can dictate where the top of this lens is, and let's say I align the top of the lens with the horizon, is it fair for me now to assume that there is no ramping down? There is only ramping up for the entire view. Is that fair to say in the vision?
One would assume, yeah, if you take away an object parallel to you, it would just appear to ramp upward, since, you know, your visual scene is cut off more or less based off your height above the surface. Yeah. So your visual scene is already limited and cut off in a certain way, essentially.
So brilliant. So now I've aligned this top of the lens to the horizon, which means absolutely every single thing in view right now is ramping up. So there is no top and bottom of vision. There is just ramping up due to perspective in the apparent field of view of the camera, which is recording a 2D image. Now, the issue that you have to explain is this vessel, when moving away towards that horizon, does not do what you would expect on a flat plane. It does not continually go upwards. At some point, this vessel will start to go down. Now, that's a very weird thing, because what it'll do is it will go away from the camera and it will appear to go up, but then at some point it will appear to not go up at all, and then at another point it will start to go down.
Stingray, very quickly, can you leave the screen share up for a few, maybe 5 minutes? Top 10 tops. I gotta go AFK for a few minutes, so we get something on the screen. Appreciate it. Yeah. And you guys got the floor, everybody. So play nice.
Yeah, so Lemon, so when this moves away, this is the issue that we've got. Everything is now ramping up, but in real observations, something weird happens at the horizon, or it starts to go down. So previously, up to the point of the horizon, it's been going up in our apparent vision, but now it starts to go down. Now, it's not a lack of resolution or resolving anything, because you are actually closer to the bottom than you are to the top. It's a huge ship and you stood on the water's edge, let's say. So the issue that you have to explain in your phenomenon is, why does it go down?
Visually, we represent a bunch of converging lines. Like we said, Stingray, you can tell what's the top or the bottom half when stuff goes away parallel. You don't have conditions where stuff is going away parallel. You're aiming downward at an angle where the surface is going off at another non-parallel angle. So the conditions aren't there to see easily what's above or below until you take something away parallel to the surface, like you did that ship, and see how it ramps. You've broken the analytic definition that we appear to have just accepted, that we can tell what goes away or above or below the level of the eyes by the ramping, by trying to reintroduce into your analytic definition something that's ramping downward, as if the top of your lens is not quite perfectly oriented toward the bottom half of vision. But we can tell when something's above or below something simply by the way that it ramps. Anything that's below the level of the eyes will ramp upward. If you're trying to reintroduce and redefine your lens to now include a section that's above the lens that is ramping down, you've changed the analytic definition of what you put in your hypothetical. Your lens is no longer just pointing down. It has a slight section that is pointing upward. And you can see the ship ramping down in that regard.
Okay, brilliant. But that's not at all what I said, not at all what I meant, but thank you for arguing against it.
So it is what it is, Stingray. People do not always explore the implications of what they say. So unfortunately, it falls on the opponent to explore it for them, and vice versa.
Indeed. So what it actually was, Lemon, is if this moves away, the bottom of the ship is going up, the black of the ship is kind of staying level, and the top is ramping down. Your issue is, in reality, I mean, I've got a flat plane here. I can't do what happens in reality. I need a curve. because this thing is going to go down in the vision. Even the bit that was ramping up previously is going to go down in vision. Not as though it's going away along a parallel plane. It's as if it's going away along a semi-parallel plane that then starts to curve away and downward. Is exactly what it appears to be in reality. But on this flat plane, there is nothing to explain that. What I was trying to get at with you is if I point this lens down, the same phenomenon happens. Things ramp up, but then actually go back down in reality, not here, because this is flat. I can't mimic reality unless I put a 1 degree curve over 69 miles in, and then it matches. I can't reproduce your phenomenon unless I have more information, and it can't just be rhetoric. It needs to be, this causes this at this rate. So anyway, your theory's got problems, Lemon.
It doesn't. In the foreground, Stingray, you already have portions of the ship that are physically above the level of the eyes. You can orient your lens rather toward this perfect horizon and try to only encapsulate the bottom half of your vision. But in the foreground, it's too late for that, Stingray. You're trying to aim down toward the horizon that forms, sure. But in the foreground, there's already information above the level of the lens. I'm looking at something that's level right here, and I can see a level line that would form a horizon, sure, but in the foreground there's already information above the level of the eyes that is part of the foreground scene that will ramp accordingly regardless of where I'm pointing the lens of my eye toward the horizon. And so these idealized principles where you're saying I got this lens perfectly oriented toward the bottom half of vision doesn't include the stuff in the foreground that already includes stuff above or below the level of the optic. So perspective is a hell of a drug, gentlemen. And we're going to need to look at these principles again.
No, perspective isn't a hell of a drug. Perspective is simply distance over size, or size over distance, and that's it. There's nothing complicated about it. And I know you guys want to have it as this magical entity that's yet to be discovered, but I'm really sorry. We know what perspective is, and it is not what you describe, which is why I'm attempting to help you figure out what it is that you are describing. When you say, just real quickly, Lemon, when you say that I can't point this down and something is above the eye level here, I can assure you I can actually point this down so that in the field of view, nothing will be above the eye level. Nothing.
There's some stuff in the foreground that's above the level of the optic, run light from that zone that's cramming into the optic. So what you're saying doesn't quite mimic reality, especially
so
your idealized principles, Stingray, do not help me solve the problem. Therefore, you cannot help me. I'm going to need a perspective and a paradigm from somebody who can help me figure out why the horizon forms over a flat plane. And sorry, Stingray, this isn't it.
So what you're saying is there is something in the foreground here which is above the camera, correct?
Yes.
Okay. When you say above the camera, do you mean in elevation from the flat plane ground? Because if that is the case, yeah, so no, there is nothing above this camera. This camera is the highest element out of the surface of the floor here, and this. This is always below the camera. It goes up to the top due to something very simple called perspective and the view frustum. That's it. There is nothing magic about this.
Okay, there's your fallacy right there. The focal point of your lens may be oriented somewhere else, but there's still light from above the focal point that's cramming into the lens, and that will ramp accordingly. So there's your fallacy right there.
Right, so look at this. This object is entirely below and always will be below this camera unless I fucking move it up.
Your idealized example forgets about the light still cramming into the optic from above the center point of the lens or the central focal point of the lens.
Right, now, okay. So now we're back to the lens. So we've gone away from the surface. Now we're saying we're back to the top half of the lens, right? So it's not about whether it's higher than the observer. It's now, or its proximity to the floor or anything like that. Now it's about the top half of the lens again, right? Are we sticking to the top half of the lens now? Right? Pick one, or is it both? Farmers, you're welcome. So anyway, just for the audience, again,
Oh, yeah, he's gone.
if you try and ask what the hell it is that these people are on about, and then you try to drill down to say, give me the cause and effect, give me the variable, give me all elements involved, what is it? And ask them to describe it. They have no idea, and they switch left and right and backwards and forwards. First of all, it's just the ground. It's nothing to do with the camera or the observer or the lens. No, it's definitely the lens and the bottom half of the lens. It's ridiculous.
You killed him. He even quit.
So I just think we need better clarification of terms from the claim. Like visual information, great. What does that mean? Because what you actually mean is just degrees in the vertical or horizontal. How are you doing, Brian? You haven't been here in a while.
I'm busy as all hell. So, good job on slaughtering Lemon. Did you catch earlier where he admitted that he has to make everything up?
Oh no. I probably wouldn't have come in. I watched like just the past 10 minutes and heard Lemon saying some things and thought I'm definitely going to get him to explain some of his claims instead of just the rhetoric. Because yeah,
what did I miss? How did Lemonberg not here anymore?
Sorry, Jose.
Stingray was very cordial to him. He just kept asking him to explain things, and then Lemon kept saying, well, it's the limiting surface that does it. Now it's the different portion of the lens that does it. Now it's the surface that does it again. And Dean did a very good job just trying to make him pick one, and he wouldn't, so he left.
Wow, so we got a few days ago, 2 times that Doofus made Gary Webenga rage quit twice in one show, and Stingray just made Lemonberg rage quit just by trying to have a conversation and back and forth. That's crazy.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.